Hi there. These video codec settings apply to every video editor using codecs such as h.264 and h.265. So this information is equally essential to not just the users of Resolve, but to users of CapCut, Adobe Premiere and Final Cut. If you want your video files to be of higher quality, take less space and be as compatible as possible, you need to understand the settings of the video codecs that you are exporting. Professional work often entails specific requirements from clients. This includes technical specifications and the settings of your delivered video files. So you better learn the settings in advance. Each setting exists to serve a specific set of purposes, which may turn out to be quite essential or downright harmful for any given project's and client's needs. Main focus on this video will be on the settings of the h.265 codec, as it is currently one of the most popular codecs used for exporting video. Encoder, Auto, NVIDIA, AMD, Native. In short, if you want high quality, choose the native option. But if you prefer much faster encoding speeds with decent quality, then you can choose the GPU, which in my case is the NVIDIA option. If you have hardware encoders available in your system, those will be listed here as video encoder options. I have the NVIDIA GPU and I also have an integrated GPU on the AMD CPU. Although the gap between the options has been narrowing, the native option, which uses Resolve's own software encoding, remains to be giving higher quality results than the faster hardware encoder options. The Auto option lets Resolve choose which encoder is best suited to each encoding task. Network optimization. Tick on or off. The metadata section of a video file is normally written after the video and audio streams, at the end of the file. This means that you would have to download the entire file before you could use it and play it back. By ticking the network optimization box, this metadata will be written and placed at the beginning of the file, enabling the use and the playback of the file, even while the file is still being downloaded to your device. Resolution, timeline resolution, standards, custom. From here we choose the resolution for our exported render. This list of resolutions here depends on the chosen codec, which defines the range of available export resolutions. The list of resolutions also consists of some of the most commonly used standard aspect ratios and resolutions. This setting defaults to the current resolution of the active timeline. Using this setting, you can queue up different render jobs at different resolutions in order to, for example, output both HD and 4K resolution media. Some file formats require specific resolutions, in which case the output size settings will be automatically set to the necessary resolution. At the top of the list, there is Custom, which opens up boxes for the resolution values for you to add manually. Use vertical resolution. Tick on or off. If the video on your export is vertical, then do check this box. When you tap the Use Vertical Resolution active, the list of available resolutions are swapped into offering the most common vertical and square aspect ratio options instead of the default horizontal aspect ratios. If your video has a horizontal aspect ratio, leave this box unchecked. Frame rate. The frame rate value comes from the timeline you have currently open, and it usually cannot be changed. To change the frame rate, you need to create a new timeline in the edit page with the frame rate you are choosing. As you have opened the timelines in the edit page, you can also switch between them in the deliver page. And this way you get to export the same material with different frame rates. Export alpha. Tick on or off. If the render format you have chosen has support for alpha channel, then you will have this option to include the alpha channel in the export or leave it out. Alpha channel works the same as with image files, as a separate channel for modifying opacity. Alpha channel can be embedded in a clip as you ingest them to Resolve, or you can create new ones in Resolve. Alpha channel enables the blending of images into one. Alpha channel does not usually exist in the final output, but during the post-production process it is often essential. As an example, a chroma key is when the transparency is based on the color of the pixels, such as green or blue. With alpha channel, the transparency information is coded using a separate channel, which is more precise and appealing than chroma keying. Alpha channel becomes essential with any kind of compositing when you want to create effects like reflection, smoke, lens flare, snow, rain, fire, or motion blur for your video image. If you don't need to include the alpha channel in your export, which you often don't, as you export for publication, you'll increase the file's compatibility and reduce the file size. Chapters from markers. Tick on or off. This feature has turned out to be very handy with YouTube, as you not only use the markers for chapter timestamping and naming in Resolve, but this data can be directly transferred to YouTube when using the YouTube export template, saving you a lot of time and also aiding the audience quite a bit, as they can now click to the part of the video they need information from, the chapter marks. You can choose a specific marker color for this specific purpose, which helps quite a bit as you often have markers for quite a lot of reasons, other than chapter marks. Quality. Automatic. Least, medium, best. Restrict to certain kilobytes. The quality, in this case, in Resolve, means the bitrate. You can set a specific number value as the maximum bitrate, or you can choose the least option for minimal file size with modest image quality. The medium option refers to a compromise between the file size and quality. And thirdly, you can choose best to get the best possible image quality, and the cost of this is of course much larger file sizes. So what is the correct value to give here? It depends on a variety of factors. Who are you delivering your content to? To what purpose? Does the file need to be easily shareable, or is the quality a top priority? As this question depends on so many factors, it won't be easy for you to find any fast, usable information from the web. This is why so many codecs, thankfully, offer few templates in the style of best, good, medium, and so on. Like most editors, you need to reserve some time for practical testing for what is the best bitrate setting in each case, unless of course your client has specified this value. Encoding profile. Auto, base, main, main 10, main 44410. The different encoding profiles add or remove certain capabilities from the use of the encoder and decoder. As the name of the profiles suggest, you can choose the color depth of 10-bit, and you can also choose the level of chroma subsampling. Using the base profile for your video assures the playback of your video on the widest possible range of devices. This limits the encoder to use only the basic features. This profile was useful back in the day when the video playback was a new thing on mobile devices. The main profile enables the use of the advanced features of the codec to be used for better quality and efficiency of the video file. Main 10 profile is an extension of the main profile. It supports 10-bit color depth and uses the 4:2 chroma subsampling level. Disappointingly, the 4:2 chroma subsampling is not supported by NVIDIA graphics card hardware, most likely because of some licensing issue. So this list, as many others here, depend on licensing and on the capabilities of the hardware you are using with DaVinci Resolve. The main 444 profile uses 8-bit color with 444 chroma subsampling, and main 44410 uses 10-bit color with 444 chroma subsampling. The main profile is the default encoding profile, and the other profiles are there to be used only when you have a specific need to do so. For example, the lower base encoding profile is beneficial only if you have a specific need for it. For example, some potato of a device cannot play back the video file using the main profile. Keyframes, automatic or specified. Keyframes are the full intra-coded frames between the group of incomplete and partial P and B frames. The more movement your video has, the more keyframes are needed to avoid the image from breaking apart because of data loss. If the frame rate of your material is 30 and you set keyframes to be every 30 frames, means that the file will have a full keyframe every second. The default recommendation is 16 for 30 FPS material, roughly half of the frame rate or half a second. This value, once again, depends on your needs. Entering a smaller value here, meaning a smaller distance between the keyframes, can improve the error resilience and random access capability, but also increase the bitrate and reduce compression efficiency. Frame reordering, tick on or off. Frame reordering is a video encoding feature that is available for QuickTime h.264 and h.265, and it is on by default. It brings more efficiency to the encoding by allowing frames to be decompressed in a different order than the display order. In a typical video file, frames are not always stored in the order they are displayed. This is because video compression algorithms like h.264 use temporal prediction to achieve higher compression ratios. Temporal prediction involves using information from other frames to encode a frame. This can be information from past frames used in P frames, or even information from the future frames used in B frames. When a video is played back, the decoder reorders the frames into their correct display order. This is typically handled automatically by the video player or decoding software. Turning off frame reordering will speed encoding performance and increase compatibility at the expense of visual quality. Rate control, constant QP, variable bitrate, constant bitrate. Here we can choose the method on how the encoded bitrate is controlled, with constant bitrate, variable bitrate, or using constant QP, quantization parameter. The oldest and thereby most compatible and inefficient of the methods is the CBR, constant bitrate, where the bitrate is maintained unchanged for the duration of the file, as the same amount of bits is assigned to every frame of video. The good thing from this is that the file sizes are predictable, and the bad thing is that the files are not only needlessly large, but the quality is not great either, as it doesn't take the potential complexity of the image into account. The visual quality decreases because the more demanding frames won't get any extra bits to be able to be reproduced with sufficient data rate and quality. This option will also give you the largest file sizes, as it wastes bits on the less demanding frames. One benefit of this option is that when you know the length of the video, you know its size. The DVD movie discs used CBR for compatibility to ensure smooth playback on even the crummiest of DVD players. This is the reason why hevc files use CBR as their default setting, to secure successful playback on as many devices as possible. Variable bitrate VBR encoding is the more advanced option from the constant bitrate, as it enables the video encoder to allocate more bitrate to scenes with a lot of motion or detail, and less bitrate to scenes with less motion or detail. This results in smaller file sizes, while also reaching higher quality than with CBR. Constant QP, quantization parameter, is a rate control method setting that is used to maintain a consistent level of quality throughout a video. The QP controls the amount of compression for every macro block in a frame, how much information is discarded during compression. QP value starts from 0, maxing out at 51. This would mean that a value like 25 would offer the best balance between video quality and file size. To find the correct value for your export, as always, you need to do some practical testing. Large values mean that there will be higher quantization, more compression, and lower quality. Lower values mean the opposite. A fixed, constant QP value means that the resulting bitrate will change greatly based on each scene's complexity. The quality will be good if you set a low enough QP, but also the file sizes will be big. Preset: very fast, medium, very slow. Video codecs such as h.264, h.265 and av1 have many features that you can ignore or take advantage from. Because there is such a long list of options, the users have these presets ranging from very fast to very slow. The faster encode you choose, the less you can expect from the end result. The very fast option will encode your video as fast as possible, but it will also result in giving the lowest compression rate, largest file size and lowest quality for your video file. Live streaming requires very fast option for faster than real-time video encoding, whereas professional video editors require the very slow option for the highest possible quality for the video files. Quite often we need to share something fast, and the quality and size of the file are not that important. Tuning: high quality, low latency. You can choose which is more important for your exported file, high quality or low latency. A higher quality video image adds to the computational complexity of the encoding process, which in turn leads to higher latency. Latency is the delay in the encoding process, the time it takes from your play command to the actual playback of the video. This latency can be reduced by leaving out some of the image and compression enhancing features used by codecs, such as h.265. For video on demand purposes, high quality is usually preferred. For video streaming, having low latency for the video is usually more important. 2-pass, disable, quarter, full. The video is encoded twice with 2-pass encoding. First, the video is analyzed on the first pass and then processed on the second pass of encoding. With constant bitrate, the 2-pass encode is useless as the bits are already set in their places. But when you use high dynamic range image quality and variable bitrate, the 2-pass encoding is where its benefits are reaped. With variable bitrate, the bitrate is dynamically assigned, even on the fly. And for this to occur effectively, the video, its complexity and motion needs to be first analyzed for the encoder to know where the bits are needed. In the second pass, the encoder uses this information to allocate bits more efficiently and optimize the quality of the outputted video. The two-pass encoding does take a longer time to render than one pass, and it requires more disk space. The options of full and quarter refer to the resolution in which the first pass of the encoding will be run. At full resolution, the encode takes up more resources but gives the best quality. Or at quarter resolution, you get speedy encode and more modest quality video. Lookahead 0 to 32, default at 16. Lookahead option is NVIDIA GPU accelerated in variable bitrate video encoding. It lets you specify the number of frames for the encoder to buffer and examine in advance of compression for more accurate bitrate allocation. A larger number of lookahead means that the encoder can take into account more of the future video data when making these decisions, which can lead to more efficient bitrate allocation. More reactive bitrate allocation can be beneficial for videos with a lot of sudden changes in the video image. Like sports content requires the encoder to quickly adjust the bitrate with a short lookahead to maintain a smooth playback experience. More predictive, longer lookahead bitrate allocation can be beneficial for videos with a more consistent video content. This lookahead does sound a lot like defining the size of the GOP, group of pictures, between the keyframes. And with lookahead you get to specify the number of B-frames. This means that while the lookahead can further improve the quality of slow-moving content, it will bring a heavy toll on the GPU, and it won't bring any benefits on the faster-moving content. The default value is at 16, which is actually close to the minimum for the lookahead to bring any additional quality. Disable adaptive iframe at scene cuts. Tick on or off. This option will remove heavier, full iframes from non-abrupt scene cuts, as it is possible that removing iframes from abrupt scene cuts would guarantee the image to pixelate from not having enough data for proper image encoding. The intra frames exist for a very good reason, as they are used as reference frames for the encoder to reconstruct partial P and B frames. Therefore, this option of removing additional iframes is relevant for video clips that are meant to be streamed, where the bandwidth limitations are most often the biggest hurdle to overcome. As the removal of iframes reduces the bandwidth requirements, they also, at the same time, increase the processing requirements, as there are more partial frames to be processed into full frames at playback. Enable adaptive B-frame. Tick on or off. If you are after maximum compression efficiency, then you should tick this box, as the addition of adaptive B-frames reduce the bitrate without much loss in quality. This option enables the encoder to adjust the number of B-frames dynamically. B-frames are in-between frames that are predicted from both previous and future frames. The compression is improved by removing the temporal redundancies between frames. The encoder can focus on using B-frames where they will be most beneficial. However, enabling adaptive B-frames can also make the video playback more complex, as there are more frames to be rebuilt for the playback, which can become choppier on less capable devices. AQ strength 0 to 15, default at 8. AQ, Adaptive Quantization, Strength, is a variable bitrate DBR video encoding parameter that defines the amount of effort the encoder puts into maintaining the quality of video frames. A larger AQS value means that the encoder will spend more time and effort trying to preserve the quality of video frames, even at the expense of bitrate efficiency. With AQ, the level of compression can be differing within a single video frame, depending on their complexity and perceptual importance of the areas of the image frame. The smaller the displays of the consumers, like phones, the smaller the amount of AQ strength will be sufficient, and vice versa. By increasing the AQ strength, you not only increase the quality and the bitrate of the video, but also make the video encoding process more time-consuming. Enable non-reference p-frame. Tick on or off. The option to enable non-reference p-frame in video encoding is used to allow the encoder to include non-reference prediction frames in the export, thus reducing bitrate. P-frames compress video by predicting from previous frames. The encoder can now create p-frames that are not referenced by any other frame in the sequence. This brings not only compression, but also the p-frames can be more freely encoded without having to worry about maintaining consistency with other frames. Processing becomes more complex and latency is increased as the decoder will need to track the reference frame for each p-frame. This option is ticked when you're after maximum compression efficiency without losing much quality. Enable weighted prediction. Tick on or off. The option to enable weighted prediction in video encoding is used to allow the encoder to assign different weights to the motion vectors used to predict a frame. Motion vectors are used to estimate the location of a pixel in a frame based on its position in a previous frame. By assigning different weights to the motion vectors, the encoder can give more or less importance to different reference frames. When this option is enabled, the encoder can give more weight to frames that are more similar to the current frame and less weight to the frames that are less similar. This can help to improve the accuracy of the prediction, and it can also help to reduce the amount of data that needs to be transmitted or stored. The quality of the encode and thereby the video image is increased with the price that the encode becomes more complex and heavier to process. Enable Temporal AQ. Tick on or off. h.264 only. AQ is short for Adaptive Quantization. It is basically a smarter way for the encoder to decide how many bits it spends to encode any given part of the video. As with many other settings, adding some amount might enhance the image and remove artifacts. But it can easily be overdone, which makes the image look worse, actually adding even more artifacts. This needs to be tested case by case. This option is available when you have the studio version of Resolve and an NVIDIA GPU. Temporal means something to do with time. In this case it means compression within a certain time frame, the group of pictures between the iframes. Spatial compression reduces the file size by removing the redundant or irrelevant information within each frame, such as color depth or detail level, while temporal compression reduces the file size by removing the redundant or irrelevant information between the frames, such as motion vectors or frame rate. Adaptive quantization strength sets the strength of AQ bias towards low detail macro blocks. The image frame is divided into macro blocks, regions that are based mainly on movement. Temporal AQ can improve the quality by allocating more bits to regions that have low motion but high spatial detail, such as a detailed background. This can make them better reference frames for future frames. Entropy coding mode: Auto, CABAC, CAV-LC, h.264 only. Entropy coding mode lets you choose which algorithm the encoder should use for compression. CAV-LC, content adaptive variable length encoding, and CABAC, context-based adaptive binary arithmetic coding, are two methods of entropy coding used in h.264 to losslessly compress syntax elements to encoded bits. With h.264, we can choose between CAV-LC and CABAC encoding. CABAC is more efficient and also more demanding for processor. CAV-LC remains as an option with h.264, as being the lighter and lower quality option. To simplify the codec design of the h.265, the option of CAV-LC was removed and all effort went to redesigning the CABAC encoding, making it faster and more efficient than CAV-LC was. Pixel aspect ratio, square, CinemaScope. First setting under the Advanced Settings section lets you override the project settings and change the pixel aspect ratio of the rendered output to either square or CinemaScope. The CinemaScope pixel, also known as an anamorphic pixel, is twice as wide as it is high, with a pixel aspect ratio of 2:1, while the square pixel has a pixel aspect ratio of 1:1. The CinemaScope pixel needs to be wider because it is used to squeeze a wide image onto a 35mm film strip and then unsqueeze it during projection to display a wider aspect ratio. Data levels: Auto, Video, Full. Defaults to Auto. Data level defaults to Auto, which simply renders all clips with the data level appropriate to the currently selected codec in the Render To drop-down menu, which is usually preferred behavior. Choosing one of the other options of Video or Full outputs all clips using the selected data range. There's a reason why this option is not available in the regular settings section, as you should only stray from the Auto option if you have a particular reason to do so. Even when you have a mix of codecs in use, you should leave the Auto option as the data level is often dictated by the codec you are using. However, many codecs accept both sets of ranges, and different software may have different assumptions on which range they read any given codec by default. So there is room for some potential confusion in this matter. For broadcast and delivery in general, the correct option would be the video level. If you're exporting DPX or EXR, then the data levels are full when you choose the Auto option. And once again, if you're unsure, leave the Auto option ticked. Retain sub-black and super white data. Tick on or off. Turning this checkbox on lets you choose to output media files that preserve overshoots and undershoots. Data that's above the maximum and minimum data levels of the data level you've selected, assuming this is supported by the video format and codec you're exporting to. Otherwise, DaVinci Resolve clips these out-of-bounds parts of the signal in an effort to keep your deliverables from violating whatever QC standards you're adhering to in your grade. This option only works for limited range data, such as YUV formats, and not for full range data, such as RGB formats. Full range data uses the entire range of values, from 0 to 255 for 8-bit RGB and from 0 to 1023 for 10-bit RGB. So there is no sub-black or super white data to retain. Color space tag and gamma tag. The drop-down menu lets you choose a specific color space and a gamma tag to embed as metadata in your rendered file. The purpose of these options is that if you for some reason need to override the settings you set up in the project settings for the color space and gamma, you can do that here. This setting defaults to the output color space if your project's color science is set to DaVinci YRGB color managed, or the ACES output device transform, if your color science is set to ACES CC or ACES CCT. You might want to experiment with this if you want to export your video to a different color space and gamma than your timeline, or if you experience unintended color shifts or gamma shifts when exporting. Data burn-in. The data burn-in drop-down menu defaults to same as project, which leaves the current data burn-in palette settings enabled while rendering. Inserting a window burn into the media being output. Choosing none disables window burns while rendering. Note that when rendering as individual source clips, individual clip burn-in presets can be assigned if they've been created in the data burn-in palette. Bypass Re-Encode when possible. When you're exporting in single clip mode, turning this Bypass Re-Encode when possible checkbox on allows you to export your video faster and without quality loss if the selected format, codec and type match the source. This means that the video data is copied directly from the source file to the output file without going through the encoding process. This also preserves alpha channel data for compatible formats. If you change the resolution, frame rate, bitrate or color space, the option will not work and the video will be re-encoded. Also, this option does not work for formats that do not support direct copying, such as MXF or IMF. This option only works for clips in the timeline to which no additional effects have been added. Doing any grading, adding a Resolve effects plugin, adding any overlapping effects or compositing to clips in the timeline, resizing or stabilizing clips or altering the output sizing of the timeline, and adding fusion effects will all necessitate re-encoding the entire clip in order to process these effects. Transitions will require processing, but only for the duration of each transition. There are many situations where this is valuable. If you want to save time and disk space by avoiding unnecessary re-encoding, or if you want to preserve the original quality of your video, especially for lossy formats like h.264 and h.265. Or if you need to export a new audio mix to a timeline that has previously been exported. Or if you want to perform simple edits such as trimming, merging or adding metadata without affecting the video data. For example, you've edited a simple cuts-only promo using footage cut from a previously rendered program, and you're exporting to the exact same format. Use optimized media. Tick on or off. When the checkbox for Use optimized media is turned on, Resolve will use optimized media when available to do the final render to save time. if your media has been optimized to the same or better format as the one you're outputting to. This is convenient. However, if you've optimized to a lower quality format than what you're outputting to, you should turn this checkbox off to force Resolve to process all clips using the original media, guaranteeing the best quality available. Use Proxy Media, tick on or off. By default, the deliver page always reverts proxies to the original source media for final output to ensure the highest quality render. Checking the Use Proxy Media box overrides this, so DaVinci Resolve uses Proxy Media for final output instead. This can be useful if you need to save rendering time while making dailies, or to quickly create outputs of your timeline to places where master quality is not necessarily needed. You will also need to check the Use Proxy Media box if you are editing with proxies and you do not have access to the original source media. Use Render Cached Images, tick on or off. When the Use Render Cached Images checkbox is turned on, Resolve will write media from the cache to the files being output to save time. If you're caching using the same or better media format you're outputting to, this can be convenient. However, if you're caching in a lower quality format than the one you're outputting to, you'll want to turn this checkbox off to force Resolve to process all media using the highest quality, original media. Force sizing to highest quality, tick on or off. When you tick on the Force sizing to highest quality, the resize filter that you selected on the edit page will be overridden and the Use Sharper resize filter is used instead. If you have set the resize option to bilinear to improve performance when working on a slower workstation, turning this checkbox on automatically renders all clips using the Use Sharper filter setting of the image scaling panel in the project settings. This can be useful when you want to export your video with the best possible quality, especially when resizing from a higher resolution to a lower resolution. You want to avoid aliasing or moiré artifacts that can occur when resizing with lower quality filters. And you want to have a consistent resize filter across all your clips, regardless of the format, codec or type. Force Debayer to highest quality, tick on or off. Force Debayer to highest quality allows you to override the setting for the project settings camera raw controls for the resolution at which the raw media is debayered. This can be useful when you want to export your video with the best possible quality, especially when resizing from a higher resolution to a lower resolution, and when you want to avoid artifacts or distortions that can occur when resizing with lower quality filters, such as aliasing, moiré or ringing, and when you want to have a consistent resize filter across all your clips, regardless of the format, codec or type. When rendering camera raw media formats that allow variable quality debayering, it's common to lower the debayering quality to improve real-time performance while grading. Turning this checkbox on guarantees that media will always be rendered at the highest available quality. Render all video tracks. When you untick the Render all video tracks box, you can choose to disable individual video tracks from the export render. This means that now you don't need to go to the edit page to select or deselect certain tracks from your timeline for the export. You can do that without leaving the deliver page. This becomes handy if and when you need to create different export versions from your timeline, like a graphics-free clean version for archival purposes. This of course assumes that you would have all your graphics on certain specific video tracks. Enable flat pass on, always on, with clip settings. The Enable flat pass lets you choose whether or not to render each clip with its grade applied. The option Off is the default, as the grades are applied to the clips when rendering. The option Always On disables the grades for every rendered clip. With clip settings chosen, the system will check each clip version's pass flat flag. If it's turned on, the system disables color correction for that version of the clip. Otherwise, that version will be rendered with its grade intact. Versions can be individually flagged by right-clicking a clip's thumbnail in the timeline, choosing the submenu of the version you want to flag, and choosing Enable Flat Pass. Enable Flat Pass disables sizing and blanking output, tick on or off. When rendering your final output, you have the option of choosing whether or not to bake in the sizing operations that have been performed. For example, you may have set up a whole set of specific sizing adjustments for the clips in a program. But then you're requested to render the project and its media as individual clips for round-trip re-delivery to the editor for further work. In this case, you can choose to either render the sizing into the final media or not. Whether or not sizing is rendered into your final media depends on the Disable Edit and Input Sizing checkbox in the Advanced Settings options of the Render Settings panel. If Disable Sizing and Blanking output is turned off, output blanking, cut and edit page sizing adjustments, color page input and output sizing adjustments, and image stabilization are rendered into the final rendered media using the optical quality sizing algorithms available to DaVinci Resolve. This is the best if your sizing adjustments are approved and final, and you want to bake sizing adjustments into the final media you're delivering. If Disable Sizing and Blanking output is turned on, output blanking, cut and edit page sizing adjustments, color page input and output sizing adjustments, and image stabilization are not rendered. And each clip will be rendered either at the source resolution, if Render at Source resolution is enabled in the individual clips mode, or to the currently specified resolution of the timeline or project. However, the sizing adjustments you've made will be exported as part of the XML or AAF file that you're exporting. This is best for workflows where the editor wants to continue adjusting sizing after you've handed off the graded project relative to the original size of the clips. Trigger script at start of render job. With trigger script at start or end of render, you have the option of triggering a script of your choosing to be executed before or after rendering a timeline. Scripts must be written for the Resolve scripting framework in either Python or Lua and placed in the scripts folder of Resolve. A pre-render script could perform tasks such as setting up the environment, initializing variables, or preparing assets before the render begins. A post-render script could handle tasks like moving rendered files to specific directories or triggering additional processes such as encoding or uploading. You could use a cleanup script to clean up temporary files, reset project settings, or perform any necessary post-render maintenance tasks. You could use an error handling or a notification script which might perform actions such as logging errors, sending notifications to administrators, or attempting to resolve the error automatically. Subtitle settings. The subtitle settings let you choose first to export subtitles to begin with, and then, when you tick the box, from 3 options on how you want your subtitles to be exported: as a separate file, as embedded captions, or as burnt into the video. The separate file option outputs each subtitle track you select as a separate file using the format specified by the export as pop-up. A set of checkboxes lets you choose which subtitle track you want to output. Burn into video renders all video with the currently selected subtitle track burned into the video. As embedded captions outputs the currently selected subtitle track as an embedded metadata layer within supported media formats. There is currently support for CEA 608 closed captions within MXF OP1A and QuickTime files. You can choose the subtitle format from the codec pop-up that appears. Export as is only available when format is set to as a separate file. From there, we can choose the subtitle format from a few most used options.